polar coordinate. So polar coordinates are r and theta. Rectangular coordinates are x and y, yeah? And there is a connection between these two sets of coordinates. The connections are provided by these three equations that you see here. X is always r cosine theta, y is always r sine theta, and x squared plus y squared is equal to r squared. And I mentioned that r can be, it can be positive, it can also be negative. Yeah, there are situations where r could be a negative number, but r, for example, being negative, like here, -3 theta pi over 2, that means you need to go to pi over 2 here, 3, and then you go to the other side. You go to the point minus. So the point in this case will be this point here, which is x equals 0, y equal -3. So basically, r negative means you need to add pi to the theta that you are given. Okay, now we move on. We did some graphing a little bit of polar coordinates. Yeah, sketch the graph of r equals sine theta. Where are the points which satisfy this equation? Well, to graph this, what did we do? We moved, this is in polar coordinates, we shift everything into rectangular coordinates. So we change this equation into a rectangular coordinate equation. And now, with these rectangular coordinates, we can see what the graph is going to be. It's a circle centered at 0, half, with a radius of square root of 1 over 4, which is half. Okay, now I want to continue with maybe 2 or 3 other examples. Yeah, just 3 examples to finish this. Now I want to sketch the graph of this polar equation, r equal to theta. So where are the points which satisfy r equal to theta? The way we're going to do that is like this. So I'm going to make a small table where I put theta here and r there, and then I will graph here. So let's start, because theta is greater than or equal to 0, I will start with theta is 0. If theta is 0, then what is r? 0. Remember, r is exactly equal to theta. So that means the first point is here. 0, 0 is this point. R equals 0 is the origin. There is no, yeah. Now, next value perhaps I can take is pi over 4. If theta is pi over 4, what will be the value of r? Also pi over 4, yeah? Pi over 4. Now, that means pi over 4 is 45 degrees. So I go on this theta equal pi over 4, I will go and find the point which with the r equal to pi over 4. By the way, pi over 4, if you take this into your calculator, it's going to be 0. Pi is 3.14, yeah? Divide that by 4, 7 something, yeah? 7? 8. So roughly 0.8, yeah? So r is 0.8. So I measure 0.8 and I put the point here, yeah? So let's say first point, second point. How about taking theta equal pi over 2? What will I get? pi over 2 also, yeah? Which is 3.14 divided by 2, it's 1.6 maybe, yes? Around 1.6. So I'm getting a point here at 1.6. And then I move on to maybe pi. If I take pi, r will also be pi. Because theta is pi, that means where are we? When theta is pi, we are on the negative x-axis, yes? And I measure r equal to pi, so 3 point something. So it's going to give us a point here, yeah? This is pi, this is pi over 2. So what we're getting is something which looks a bit like this. And let's say I now move on to the negative y-axis. Theta is 3 pi over 2. R will also be 3 pi over 2, which is maybe around 5, yeah? Around 5, so 5 point something? Around 5. So that means we are down here at 5, yeah? At 3 pi over 2. So this continues like this. And finally, one last point. If I take 2 pi, r will also be 2 pi. But theta being 2 pi, where are we on the plane? Positive x-axis, and we are at 6.3. So we go here, 2 pi. So, and you will get a shape which does something like this. And this shape is called the spiral. Yeah, it is a spiral. And it continues around and round and becomes bigger and bigger as theta becomes bigger and so on. So that is the graph of the equation. What equation? R equal to theta in polar coordinates. So r equals theta in polar coordinates is this spiral. It's called the Archimedean spiral. So it's going like this, going around and becoming bigger and bigger. Yes? Yeah, remember theta. What is theta in polar coordinates? Theta is the angle from the point, yeah? This is the theta, yeah? It's the angle between the line OP and the positive x-axis. This is theta, yes? Do you agree with this? Now, suppose the angle theta is pi over 2, 90 degrees. That means where is the point P here? Where is the point P? If theta is 90, like pi over 2, where it will be on the y-axis. Do you understand? Suppose theta is pi. So where are we? Pi. So we are 180. So where is this point P then? It's going to be on the negative x-axis, yes? Do you understand it? Yeah, like that. So you measure your angle from the positive x-axis. Pi over 2, we are on the y-axis. Pi, that means we have reached the negative x-axis. 3 pi over 2, negative y-axis. 2 pi, we are back to the positive x-axis, 2 pi, and so on. So you kind of go around, depending on the values of theta, you will be somewhere on the plane, either on the axis or somewhere on the planes. Okay, so that was fine. Now a couple more examples. Here is an equation which looks a little bit more, which looks a bit harder to graph, but we can do it. Again, we will do it by considering the values of theta, the way they change, and so on. Now, to understand what we're going to do, you need to realize that cosine theta at 0 it's equal to 1, and at cosine 0 is 1, cosine, and then it decreases until cosine pi over 2, it becomes cosine pi over 2. If you take your calculator, you should know these values, by the way, girls, if you really want to be 0, yes. So the cosine kind of changes from 1 to 0, from in the interval 0 to pi over. So let me study this interval, and take some values of theta. So when theta is 0, what is the value of r now? Let's see. What is r? 5, exactly. 5. Yes, 5. So I can start by plotting this point. That's the first point I can plot. When theta is 0, our function is equal to 5. So that means, where are we when theta is 0? Where are we? On the positive x-axis, and r is 5. So we count 5. 1, 2, 3, 4, 5. So this is the first point. And then when theta reaches pi over 2, that the r now has gone down to 3. So 1, 2, 3. So basically what happens here is that our graph did something like this. And I can take different other values of theta, yeah? And you will see between 0 and pi over 2, you will see you will get r sometimes 1, sometimes, so it not 1, coming down from 5 to 3. Now, the other interval I need to look at, the next one will be pi over 2 to pi. Because in this interval, cosine goes from 0 to minus 1. Yeah, when theta is pi over 2, I already have r equal 3. So now I'm starting basically from the point 3 here. What happens when theta reaches pi? 1, yes. The r will be equal to 1. So it's going to be 1 here. So, and our graph, in fact, will do something like this. Okay. You can take other values of theta if you want, but I'm just giving you the and then what do you think the next interval will be? From pi to 3 pi over 2. Let's see what happens here. At pi, we already know that r is going to be 1. And at 3 pi over 2, you can check your calculator. You are going to you are going to get 3. Yeah, substitute r 3 plus 2 cosine 3 pi. Cosine 3 pi over 2 is actually 0, so you will get 3. Now, where are we? Because theta is 3 pi over 2, Where are we in the plane? The negative y-axis. So now we are actually down here at 3. Because I'm writing the y coordinate, it's going to be -3. And in fact, what will happen is the graph will look a bit like this. And finally, the last interval to cover the whole plane is to see what happens from 3 pi over 2 to 2 pi. Of course, we know that at 3 pi over 2, we have 3. So this is this point. And then at 2 pi, we come back to 5. And actually, the shape is a bit like a heart, which is on its side. So that is basically the way you could graph, this equation 3 plus 2 cosine theta. This is called the limaçon. It's like a French word for this shape. Are we okay with this? Yeah. Okay, and you can see it here. It's the different stages until you get the full graph. Finally, I want to sketch this one. Sketch the graph of this equation. We're going to do it in the same way by splitting this into 0 to pi over 2, pi over 2 to pi to 3 pi over 2, etc. So we'll do exactly the same as we did just a moment ago. So let's say theta in each interval. So in each interval, we take some values of theta. So here, again, I will take 0 and then find the r and graph. Okay, when theta is 0 and you substitute, you will get 2, yeah? So that means we are starting our graph at this point 2 here, yeah? R is 2. And so that's x, and this is y. As theta reaches pi over 2, yeah, r becomes 0, exactly. So we're starting with 2, and then theta, of course, increases, but r decreases, and in fact, you will get something which will look a bit like this. Okay? By the way, suppose I take theta equal to pi over 4, yeah? At this point, theta is pi over 4. Can you see what the r will be in that case? What will be the r when the angle theta is pi over 4? Check that. 0.5? Okay. So basically, yes, this r has already decreased from 2 to 0.5. Yeah, it's 2 minus square root of 2, yes. So that will be 0. Etc. So as theta increases like that, pi over 6, pi over 6, pi over 4, pi over 3, the values of r will decrease until they reach 0. So we get this shape here. And then what happens when theta goes from pi over 2 to pi? So we are basically in quadrant 2 this time. Yeah. At pi over 2, we know that we're starting from 0. And at pi 2 again, so it's basically coming into this point here the same way, in a symmetrical way. Like this. Okay. And then the third interval, what will be the third interval we need to look at? Yeah, so from pi to 3 pi over 2. So this, at pi, we know that we are starting from the 2. And at 3 pi over 2, 4. Yes, so 1, 2, 3, 4. So we're coming down to the point minus 4 here. So we're basically doing this. And you can see where this is going. Yeah, it's another heart, basically. And from 3 pi over 2 to 2 pi, we already have this 3 pi over 2 is the 4. So we're starting from 4 here. And at 2 pi, it's the same as 0. Yeah, we're coming back to the same point, and the value of r will be 2. So we're coming back to this point here. So that is what's happening as theta changes from 0 to 2 pi. R is changing in this way. So first from 2 to 0, then from 0 to 2, and then from 2 to 4, and from 4 to 2. That's it. You can see the way it's graphed, what we just did. Yeah, from here to here, and then the different intervals, quadrants, etc. Okay, there are some examples, but I will not do them. You will never really be asked to graph these things. They're not easy to graph. So we'll just leave it there. I want to perhaps just do a couple of these questions. Okay. Let's say we want to do this 2 here. Plot the given polar point, 2 pi. So what is this point, 2 pi? This is r, this is theta. So what is this point? It's on the negative x-axis. And what is its distance from the origin? So it's actually the point, this point here. Yeah. So if I call this point B, say, yeah, B is here. And what are its rectangular coordinates? X is -2, Y is 0. That's it. So rectangular coordinates -2, 0, like this. These 3, r is -2 and theta is pi. So if I want to graph this point here, remember pi, yeah, but r is negative, so I need to go to the other side. And what is its distance from 0 to, so in fact, I'm going to come back to this point here. If I call this point C, then C is here. And you can see in that case that x will be 2 and y will be 0, like this. By the way, you can find x and y by what is x? R cosine, yeah? So r here is minus 2 cosine pi. You will see that it will give you the 2, yeah? The same thing with y. Y will be r sine theta. Of course, you will see that it's going to give you 0, like this. So you can do this with all the other points, exactly the same. So sometimes to find x and y, you need to use the rule x equal r cosine theta and y equal r sine theta. So you need to do that. So here x will be minus 3 cosine 3 pi over 2. So you can find x, you can find y, minus 3 sine 3 pi over 2. And then you can graph. You can do it this way. Find x and y, and then graph the point. By the way, here, cosine 3 pi over 2 is 0, so? Yes. So that's 0. And this is 3. Yeah? So 0, 3. So this is the point. Okay, no problem. I think this is fairly easy. For this one, we want to find the polar representation of this is x, this is y. So you need to find r and theta. Yeah, so you want to find r and theta. So let's see where is this point. Minus 1, 1. So that's where the point is. So theta will be this angle. So, okay. So how can we find theta here? Tan minus 1, yeah? Tan minus 1 of y over x. Now, I'm not putting theta yet. I'm just going to find this angle first, because you will see it's not exactly the theta. This will give you minus pi over 4. So, minus pi over 4, which is actually this angle here. This is what we are getting. But to get the theta, yeah, you need to add a pi to this. So theta is really pi minus pi over 4. So you basically take this angle and you add pi to it because of where the point is. So you have to be a little bit careful about this. Theta is clearly not minus pi over 4. Yeah. So add theta. So add pi, sorry. Add pi. That means you will get 3 pi over 4, huh? And that's okay. 3 pi over 4 looks perfectly fine. And then r, with this theta, r will be the square root of, yeah, so minus 1 squared plus 1 squared, which will give us square root of 2. So this is one representation. R equals square root of 2, theta equal 3 pi over 4. Perfectly okay as polar coordinates. No, you don't always add the pi to theta. It depends on where the point is. And if your point is in quadrant 2, you add pi, yes. If the point is in quadrant 1, you will not need to add, because you can check. Yeah? If you take the point, for example, 1, 1, take tangent minus 1, 1 over 1, it will give you exactly pi over 4. Now, that's exactly the theta we are looking for. There's nothing to do. There is nothing we need to do here. Do you understand? So you don't have to always add the theta. No. So it just depends on where the point is in the coordinate plane. Quadrant 1, you don't add anything. Quadrant 2, you need to add pi. If you are in quadrant 3, I think you need to add pi, yes. You need to add pi. Sorry? Quadrant 3, you need to add pi. We can check this, yeah? We can check. Give me a point in quadrant 3. Negative 1? 1, yeah? Oh, and negative 1, sorry. Negative 1 and negative 1. Now, if you take tan minus 1, you will get pi over 4. So, if you take tan minus 1 of minus 1 over minus 1, pi over 4, which is this angle. Is that our theta? No, our theta is all of this. So you need to add pi in quadrant 3. So these are the rules if you want to write them. If your point is in quadrant 1, don't do anything. If it is in quadrant 2, add pi. Quadrant 3, add pi also. And then in quadrant 4, you will need to add 2 pi. You need to add 2 pi here, because you will get a negative number. So if you want to get all of this theta, so you need to add the pi to it, yes, 2 pi. So these are just a little bit of trigonometry stuff. Okay, now what else can we mention here? Okay, no problem. This is R. This is very easy, no issues. This is R and theta. You want the rectangular coordinates. That means you want X and Y. You use the rule. X is R cosine theta. Y is R sine theta. Very easy. No problem. Just substitute and you will get them. Sketching graphs. I think we did R equal something, R equal a constant. What is R equal for? It's going to be? We graphed R equal something, R equal a number. What did we get? A circle, yes, this is a circle. Where are the points which have an R equal to 4? They're all in a circle of radius 4, that's it. Do you understand it? Yeah? You can, of course, you can change this into polar coordinates, into X. If you want, you can change this into X and Y. What is R? The square root, yeah, of equal to 4. Then you square both sides. You get X squared plus Y squared equal to 16. Circle of radius, the center is 0, 0. The radius is 4. Yeah. But actually, no need to do this. Yeah? The points which have an r equal to 4, they're all around the origin at a distance of 4 from the origin. This one, same thing, yeah? It's a circle. So in general, r equal a constant, r equal a number, will always be a circle of radius, whatever it is. This one, we also did something like this. Do you remember what was the graph? It's a straight line, yes. It's a straight line where all the points have a theta equal to pi over 6. So they're all on this line where the theta is pi over 6, which is 30 degrees. Yeah. So all these points have a theta of pi over. Same thing here. 3 pi over 4 is okay. All right. Okay, let me do 24 and then I will stop here because you will not get more difficult than this. So I want to graph this one. R equal to cosine theta. R equal to cosine theta. We did like a similar example like this. To do this, we're going to use the fact that cosine theta is, what is r cosine theta? X, huh? X. So that means I can write cosine theta as x over r, yeah? And then I will substitute it here. And yeah, so I will get r equal to 2x over r. And then I will multiply both sides by r. That means r squared is 2x. Yes or no? Yes? So from here, not here, not this one. I'm solving this one, no? And then from here to here to here. Now, what do you think the next step is? Yeah, r squared is actually x squared plus y squared. Remember, r squared is x squared plus y squared. So I will use it here. Equal to 2x. Now, what do you think we should do here? We'll take the 2x to the other side. Okay? So that means x squared minus 2x plus y squared equal to 0. Are you okay with this? Now, what do you think we need to do next? What do you call that? Completing the square. Do you know this method of completing? I want to complete this square, add something to it to make it into a square. And what do we add to it? We take the 2 here, we divide it by 2, we get 1, and we take this one and we square it and we get 1. That means I will add the 1 and I will subtract the 1. Plus y squared equal to 0. Now these 3 terms are a square. They are a perfect square. What square is it? X Yes or no? Yes, it's this number here that you put here, basically, always. And with a minus because of this minus here. There's a minus, you put minus. There's a plus, you put. And then plus y squared, and the minus 1, kick it to the other side, it becomes 1. Now we get a really nice equation, which we know what it is. What is this? Circle. What is the center of this circle? 1, 0. What is its radius? 1. That's it. So this is actually a circle centered at 1, 0 with a radius equal to 1. And that is the final answer. I think they're asking us to sketch, yeah? Sketch. So we can now graph this. It's easy to graph it. So center that 1, 0, yeah? Which is here. And the radius is 1. So it goes exactly through 0, 0. So like this. So this is 2. This is 0. Yeah, this will be 1. This will be minus 1. And we get this circle. Is that okay? Yeah? So that's basically this section on graphing and polar coordinates. Now, I want you to put your names on this attendance sheet, please. And then I will take a few minutes to... Sorry? A pen? Yes. Thank you. Can you pass that? double integrals in polar coordinates. So how do we use these polar coordinates? We've just spoken about the polar coordinates r and theta. We said various things, graphing, this, that, but how do we use them in integration? They're actually really, really important. They're very useful. They will allow us to calculate some integrals which would be very difficult to calculate without the polar coordinate. So I will start with an example. Suppose you want to calculate this integral, the integral of this function, x squared plus y squared plus 3 over the region R, where R is this circle here that you can see of radius 2 centered at the origin. So I want to calculate this double integral. Now, using x, normally what do we say? We say this dA is dx dy, yeah? You put here dx dy, then we split this double integral into two integrals, one with respect to x first maybe, and then with respect to y, or perhaps with respect to y and then with respect to x. So we do that kind of work with x and y. Here, not possible to work with x and y, so we are going to work with r and theta, polar coordinates. Now, to do that, we need to understand certain things. That x squared in polar coordinate, x squared plus y squared can always be replaced with r squared. Very important. Okay? So whenever you want to use polar coordinates and you see x squared plus y squared, replace that with r squared. Okay? Now, the other thing which is also important is the dA. Before it was dx dy. Here r dr d theta. Very important. dA should be replaced with r dr d theta. Now, so let's see then, what is this integral here? How are we going to calculate this integral? Now, in the region R, think of the region R, think of a point there in the region R. It's theta. If you want to cover the whole region, theta will go from where to where? If you take a point here, for example, what is its theta? 0. And you move around. If it's here, it's going to be pi. If it's here, 3 pi over 2. And then you come back. So theta really goes from 0 all the way to 2 pi. If you want to cover the whole circle, theta will have to move from 0 to 2 pi. How about the r? If you take a point, for example, 0, 0, what is its r? If you take the point 0, 0, which is the center, what is r there? 0. And then maybe you take a point here, the r will be 1. So basically, to cover the full circle, r should go from 0 to not infinity. We are inside the circle only. What is the radius of the circle? 2. So the maximum value for r will be 2, from 0 to 2. So r will go from 0 to 2. Once we have this, it's easy now to calculate this integral. So it's going to be, let's say I start r dr d theta. Now, the bracket. What is the bracket? What is this here? R squared, huh? Plus plus 3. Then r will go from 0 to 2. And theta will go from 0 to 2 pi, like this. And now we can do this integral without too many problems. So I'm going to keep 0 to 2 pi. It's okay. Then 0 to 2. But now open the bracket. What do we get if we multiply? R to the power of, like this, power 3 plus 3r dr d theta. Are you okay with this? Now let's calculate this integral with respect to r. Very easy to calculate. So let's put 0 to pi. What is the integral of r power 3? Good. What is the integral of 3r? 3r squared over 2. This from r equal to 0 to r equal 2 d theta. Now substitute r equal to inside. So that will give us r power 2 to the power of 4, which is 16 divided by 4. So that's 4 plus 6. I think it's 10, yes? Yeah, the whole thing is 10. Yeah, 10. Now, 10, you can take it out if you want. Yeah? And then what is the integral of d theta? Theta. From 0 to 2 pi. Now substitute 2 pi, yeah? Multiply by 10, 20 pi. That's it. That is our final value for this integral. So it's like 60 something if you want to write it as a number. So this integral that we had at the beginning is equal to 20 pi, like this. Do you understand this? This basically is what this section is about. How do we calculate integrals by using polar coordinates? So these are, usually there is always a question like this. In your test 3, you will see 1 or 2. In the final exam, you will also see 1 or 2 like this. So really important. So what you need, like I said, is always replace dA with r dr d theta. If you see x squared plus y squared, then this should be replaced with r squared, and then you can calculate the integral. Okay, let me just... Now here is basically a general rule that is given here. Suppose that f of r theta is a continuous function in the region R where theta goes from alpha to beta. So that's where the values of theta are. Yeah. And R, like if you compare this here, what was alpha and beta in the previous example? 0 to 2 pi, yes? This was 0, this was 2 pi. And R goes from a function of theta to a function of theta like this. What was in the example, what was this here? 0. What was this? 2. Yeah. Then, yeah, you want the integral of the function f over r, then you integrate with respect to r from this to this, which was 0 to 2 before, from here to here, and then whatever the result is, you integrate it with respect to theta from this angle to this angle. So something like this. So here is an example of where we're going to use that rule. So I want to find the area of this region R here. The equation of this curve is R equal to minus 2 sine theta. Okay. Now, if you take a point inside, anywhere on this region R, then this is the R. R will go from 0 to, not to the curve, to this curve this time. Yeah, to minus 2 sine theta. And the theta, you can see that by taking your point, theta again, to cover the whole region, theta will have to go from 0 to 2 pi, like this. Then, by doing this, we are covering the whole of this blue region there. So, we can now say that the area of this region, which will be the double integral, like this. So, what is dA? I should replace it with r dr d theta. So first integrate with respect to r. From where to where? 0 to minus 2 sine theta. Thank you. Like this. And then the answer of this integration, I will integrate it with respect to theta from 0 to 2 pi, like this. And now it's really not, I hope, not that difficult to integrate, but yeah, okay. Oh. So let's integrate this. So it's going to be 0 to 2 pi. What is the integral of r with respect to r? Huh? R squared over 2. Yeah, so it's half of r squared then, like this. From 0 to 2 minus 2 sine theta, and then d theta, okay, like this. Let me continue here. So 0 to 2 pi. Now substitute. All of this comes here. Yeah? So it's going to be half 2 minus 2 sine theta squared. And when we substitute the 0, it's 0. So it's going to be this d theta. Are we okay with this? Okay. Now, what do you think the next step is good? Before we can integrate, what do we need to do? Yeah, we need to open the square. We need to, this square here needs to be open. We cannot integrate it like this. So it's going to be the integral from 0 to 2 pi half, and then 2 squared, which will be 4, and then this times 2. So minus 8 sine theta, and then plus 4 sine squared theta, all of this d theta. I can remove the half by way. Let's multiply by half. So it's going to give us, yeah, so it's going to be the integral from 0 to 2 pi of 2 minus 4 sine theta. I can integrate this. That's not a problem. Now the third one is a slight problem, but you have seen this in calculus 1. So I can integrate 2. What is the integral of 2? 2 theta, yeah? From 0 to 2 pi, no problem. The second one, 4 sine theta plus 4 cosine theta, that's okay. But the square there is a slight problem. You need to do a little bit of work here. How do we integrate sine squared or cosine squared? Do you remember? Huh? Sine squared theta, you integrate it by writing it as half 1 minus cosine 2 theta. These are called the half angle identities. You should have seen these in calculus 1. Yeah? Yeah. So it's basically sine squared. If you want to integrate it, you need to replace it with half 1 minus cosine 2 theta. Because then we can integrate the 1, we can integrate the cosine 2 theta, no problem. So therefore, here, so let me rewrite this. So 0 to 2 pi, okay, 2 minus 4 sine theta. And then 2 multiplied by this, 2 with the half will go, yeah? So it's going to give us plus 1 minus cosine 2 theta d theta. Now we're okay. I can integrate all these terms without any problem. Now, so I will complete that here, because this one we did it actually already. 3.1 is the one I just did at the beginning. So let me complete this here. What 2 plus 1, so that gives us 3, yeah? So it's going to be 3 theta. Then we will have a minus 4 sine theta that we need to integrate. So it's going to be plus 4 cosine theta. We already mentioned that. And then the minus cosine 2 theta. Yeah, it's half. Whatever the number is here, it's 1 over 2. 1 over 2 sine 2 theta, and we will evaluate this from theta equal to 0 to theta equal to 2 pi, like this. Let me just remind you here, what I used is that the integral of cosine a theta d theta is 1 over a sine a theta. Yeah. You need to divide by the constant a, whatever it may be. Okay, now we substitute. Actually, the only term which will give you something is the 3 theta, because the others are the same at 2 pi and 0. So they will all cancel. So the final answer here will be just 6 pi. Are we okay with this? Yeah? What I mean is that, you see, if you take the function cosine theta at 2 pi, it's going to be 1, yeah? At 0, it's also going to be 1. So 1 minus 1 is going to give you 0. Same thing with sine 2 theta. At 0 and 2 pi, they're exactly the same value. So because there is a minus there, then it will also be 0. So the only function which will not be 0 is the 3 theta. 3 theta, when theta is 2 pi, 6 pi. When theta is 0, 0. So in the end, the final answer of this integral is just 6 pi. Okay. Let me just, I will not do these for the moment. I will leave that for the next class. I just want to, yeah, okay. Let's do this one. Yeah. So this is the kind of question you may see if you want in your test. So I want to. This is like the first example we did in this section. You want to find the integral of the square root of x squared plus y squared, where r is the disk x squared plus y squared less than or equal to 9. This is basically the inside of a circle of radius 3, yeah, of radius 3, that's it. So let's shift everything into polar coordinates, okay? So in polar coordinates, integrating over r means I need to integrate r from 0 to 3 and theta from 2 pi. The square root of, remember, x squared plus y squared is r. So the square root is r squared. It's going to be r, yeah? And dA, r dr d theta. That's it. R dr d theta. Very easy. Now we can integrate this. R multiplied by r is r squared. So it's going to be 0 to 2 pi. Now r squared dr is going to be r cubed over 3 from 0 to 3 d theta. Now, when you substitute, 3 to the power of 3 is 27, divided by 3, 9. Yeah, 9 d theta. Yeah, which means 9 theta when theta from 0 to 2 pi, and very easy, substitute 18 pi, very simple. Does that make sense? Yeah, like that. Let me do this one. I will change it a little bit. I will say, well, R is half the disk with y greater than or equal to 0. So I just want to change a little bit this question. So here, the region R this time is, what is this x squared plus y squared less than or equal to 4? Circle of radius 2, yeah? But I'm only taking y positive. That means half the circle, yes. I'm only looking now at this region, only. I'm not looking at y negative, the other side, yeah? So I'm just looking at this region, R, like this, half the circle. Okay, now in this region R, now in R, of course, again, x squared plus y squared will be r squared, as always, yeah? dA will be r dr d theta. Now, r will go from 0 to 2, but theta 0 to pi only, yes? Because you can see now, if you take a point inside to cover the full region R, theta will go from 0 to pi only, like this. After that, we then say, okay, so the integral then will be is the integral from 0 to 2 and 0 to pi e to the power of minus r squared, and then dA is r dr d theta. Are you okay with this? Yeah? Because what you see here is minus r squared. Yes? Okay, now I can integrate this part by doing, what is the integral, the derivative of this? 2r. It's almost this. So I can put, you may remember that what we can do is we can put 2 there and half. I can even put minus so that I get exactly the derivative there, and a minus like this. So it's going to be minus half. So this number minus half, take it out, 0 to pi, and then e minus r squared. Let me remind you, what I'm doing here is that if you have the u dash eu that you want to integrate, that means if you have here the derivative of this, then what is the answer here? if this, no, if this is exactly the derivative, like let me say this. For example, if you have 2x ex squared, what is this integral? Ex squared, that's it. I think I mentioned this many times. If you, what is the derivative of x squared? 2x. That's it. So that means it's just ex squared. For example, cosine x, e sine x. What is the integral of this? E sine x. Because what is the derivative of sine? Cosine. But sometimes, for example, if you have x squared ex cubed and you want to integrate this, then you need to, because this is not exactly the derivative, yes? What is the derivative of x cubed? 3. So put 3 there, but divide by 1 over 3. Do you understand? So this will give you 1 over 3 x cubed, like this. All of these are things you would have seen in Calculus 1. So I'm just reminding you of this. So now let's get back to our example. So what we have here is a minus half. This minus half, take it out. And what is left is e minus r squared from 0 to 2, and then d theta. Now substitute. So it's going to give us minus half. Yep. Integral 0 to pi of e minus 4. Yeah? Minus 1, like this. D theta. This is a quantity you can take it out, no problem. It's going to give us minus e minus 4 minus 1 by 2. And then the integral of d theta from 0 to 5. And in the end, we are getting what? Yeah, this minus will give you, yeah. I'll write it like this. You will see that it's, so it's going to be 1 minus e minus 4 over 2 multiplied by the pi, and that is the final answer of this integral. Okay? If there are any steps you're not sure about, you can check them. Yeah. And I think we will stop here today, and that's enough. Any questions? Anything you want to? Yeah, it's okay. This one? This one? Yeah, okay, let me just, so what I had there was the integral from 0 to 2, e minus r squared times r, like this. What I do is I write this. What is the derivative of minus squared? Derivative of minus r squared? Minus 2r, yeah? And because I only have r here, I can put minus 2r, but I need to divide. Here I multiply by minus 2, yeah? So I need to divide this by minus 2 also. Do you understand it? And then e minus r squared d theta. Now, this is exactly the derivative of this. So it's going to give us minus half, this number, and then this is the integral. This integral is e minus r squared from 0 to 2, which is what I wrote. So that's where the minus half comes from. It's just to make this r as the derivative of minus r squared, like that. Any other questions? Anything? So these are the type of things you would have done in Calculus 1, but I'm not sure. Okay, thank you and have a nice weekend, girls, and enjoy your. Thank you.